Hello everyone, my name is Mikai. I am the engineer with the water resource team. As you are aware, the new water dam for our local council here is currently in the investigation and design stage. Today, I will be discussing some of the key engineering tasks involved and outline the main stakeholders for this project. Let's have a look at engineering disciplines required for the investigation works. Firstly, the geotechnical engineering. Geotechnical engineers are responsible for assessing the ground conditions to ensure the foundation stability. They will conduct various tests such as CPT tests and borehole drilling to gather comprehensive geotechnical properties. This is crucial for designing a stable foundation, preventing issues such as ground settlement. Next is the hydrology engineering. Hydrology engineers study water flow, surface runoff, and rainfall patterns. They model the catchment area to predict and determine the dam storage capacity. Their analysis helps in spillways design, flood controls, ensuring the dam can handle extreme weather conditions. Next is the environmental engineering. Environmental engineers will conduct comprehensive environmental impact assessments, develop pollution control strategies, and ensure the project complies with environmental regulations. Their goal is to minimize environmental disruption and protect local ecosystems. Next is the civil engineering. Civil engineers oversee the overall investigation and design of the dam. They integrate findings from other engineers to develop a comprehensive design. They also plan the layout, manage project timelines, ensure the project is both feasible and sustainable. Next is the structural engineering. Structural engineers investigate and analyze the forces acting on the dam, such as water pressure, wind, and earthquakes, to design a structure that is both safe and durable. They also oversee the construction process to ensure the dam is built according to the specification. Lastly, the others, including materials, electrical, mechanical engineering, and surveying, not as critical as other disciplines, but also play crucial roles in the investigation stage. These engineers gather essential information for selecting appropriate materials, designing the power system, specifying spillway gates, and conducting precise site surveys. They also assess the long-term durability and performance of these components to ensure the dam's reliable operation. Now, let's have a look at critical design requirements for a dam wall. Firstly, the structural design. The dam must be designed and engineered to handle a range of forces, including water pressure, earthquakes, and landslides. Ensuring the dam can withstand these various stress conditions is crucial for maintaining its structural strength, safety, and reliability. Next is the foundation design. Foundation design is a critical aspect of our dam, involving a thorough investigation, preparation, and design to ensure it can support the dam without excessive settlement. This includes various components such as laboratory testing, load-bearing capacity design, settlement analysis, consideration of seismic activities, implementation of ground improvement techniques like piling and grouting, installation of drainage systems, and the design of monitoring system to provide real-time data on the foundation behavior. Next is the spillway design. Adequate spillway capacity is essential to properly handle excess water during flood events and prevent overtopping. The proper spillway design ensures that the dam can efficiently release excess water, minimizing the risk of downstream flooding and ensuring the continuous safety and functionality of the dam structure. Next is the seepage design. Seepage control through the dam is crucial to prevent erosion. Effective seepage control measures such as barriers and drainage systems not only help conserve water resources, but also ensure the long-term integrity of the dam structure and maximize its lifespan. Next is the materials design. The materials used must be durable and suitable for the site conditions. High-quality materials ensure the dam can withstand various conditions like corrosion and erosion, maintaining the dam's functionality throughout its design lifespan and continuously protecting the downstream area. Lastly, the others, including safety and monitoring systems and environmental impact design. Safety and monitoring systems such as regular monitoring of the dam's performance, emergency spillways, and early issue detection instrumentation are essential. Ecological and social impacts should be always taken into account in the overall design. Here is a chart showing the main stakeholders in this project. Number 1, local council, the client and decision maker of the project, presenting the public interest. Number 2, engineering consultants and construction contractors. They are the various experts and companies responsible for designing and building the dam, ensuring that the construction meets to the specified design requirements and complies with Australian quality standards. Number 3, government bodies. They are responsible for issuing permits, ensuring compliance with safety and environmental regulations. Number 4, local communities, like residents and business that will be affected by the dam, who may have concerns about relocation, water access, and environmental impacts. Number 5, environmental groups. So they are the organizations focused on protecting local ecosystems, which may provide input on minimizing ecological disruption. Number 6, others, including water management authorities, emergency services, are the founding organizations. So, by bringing together experts from different engineering fields and listening to everyone involved, we can successfully design and execute a project that meets technical, environmental, and community needs. Working together ensures that the dam project is done right, benefiting to our community. Thank you for watching. You can reach me at meet.kai@hotmail.com for any questions or discussions. I look forward to hearing from you.